I'd like to welcome everyone to the webinar series of the Cybersecurity and Information Systems Information Analysis Center, CSIAC. Today's presentation is entitled Blockchain Applications, Security Promises, and Internals. My name is Steve Warzala. I am the CSIAC Outreach Manager. A couple of administrative notes before we begin. First, all phones have been muted except for the presenters. Questions may be asked at any time during the presentation by utilizing the chat function. Time permitting, your questions will be answered at the end of the presentation. Today's briefing slides will be posted on our website within a few days. I'd also like to take a moment to acknowledge and thank our sponsor, the Defense Technical Information Center, DTIC. The funding that DTIC provides enables CSIAC to conduct these webinars. It's my pleasure to introduce our presenter for today's webinar, Dr. Richard Tang. Richard is an assistant professor in the Department of Electrical Engineering and Computer Science at Syracuse University. His research is broadly focused on distributed systems and security, with a current emphasis on applying secure multi-party computations and building trustworthy key value stores. Dr. Tang earned his PhD in computer science from the Georgia Institute of Technology. I will now turn the presentation over to Professor Tang. Good afternoon, Richard. The floor is now yours.
Hello, Steve. How are you?
Good, good.
Hello, everyone. Today's presentation is entitled Blockchain Application, Security Promises, and Internals. As Steve mentioned, I'm a system professor from EECS department in Syracuse University. It is my great pleasure to give this presentation here in Cybersecurity and Information System Information Analysis Center. So this is the outline of today's presentation. First, I will give an introduction of the problem, basically introducing blockchain and Bitcoin. And then I will talk about the application scenarios and the interfaces exposed by blockchain. After that, I will talk about the security promises of blockchain. By the end of the presentation, I will treat blockchain as a sort of a white box and sort of dig into the internal mechanisms of blockchain. Okay, so let's start. Blockchain and Bitcoin is a kind of a cryptocurrency. So let me start my presentation by quoting this sort of a textbook definition of what a cryptocurrency is. This is quoted from Wikipedia. A cryptocurrency is a digital asset designed to work as a medium of exchange that uses cryptography to secure its transactions, to control the creation of additional units, and to verify the transfer of assets. At the end of this year, you probably heard the term Bitcoin, Ethereum, and Litecoin. Those are the popular currencies on the market. But you may wonder, comparing to the traditional currency, let's say US dollar, how do we compare the concept of Bitcoin with the US government issued currency? So here I will talk about what is the same, what is similar, and what is unique, what is different from US dollar. To start with, let me quickly review government issued currency or fiat currency using US dollar as an example. So for any fiat currency, its workflow involves with sort of two steps in abstract. The money has to be created by someone, a mint, let's say, and then money is being circulated among asset owners through transactions. So this is the workflow for US dollar. It's also the workflow for Bitcoin. So Bitcoin has to follow the same workflow as well. But designing a new currency does not stop here. Security is something you have to take into account upfront when you design a new currency. For example, for US dollar, there are at least 2 threats that has to be mitigated. The first threat is print fake money, right? So if the money can be printed in any place, then this money is worthless. So US dollar achieve this security by making the dollar bill anti-counterfeit. It's very difficult to copy a US dollar, and you cannot print US dollar using your home printer. And then the place where the money is created, the mint is safely guarded. So when it comes to Bitcoin, the same level of security has to be achieved as well. The second threat, called double spending, is a sort of more specific to digital currency. So currency, that's when you use credit card. Right? So when you swipe your credit card, the transaction is being recorded by the credit card organization, let's say Visa. Visa maintains a database called a ledger database that records all the transactions. And the ledger database has to validate the transaction. So here is a classic attack called double spending, which basically says that a money sender can possibly issue 2 transactions that spends the same coin or same money. So here is an example on the bottom right corner of this slide. You can see there are 2 transactions from Joey. And Joey can spend the same money in a transaction involving John and in another transaction involving Jane. So this should be prohibited. And in real life, Visa ensures that there is no double spending. Only one transaction will be validated. So Bitcoin is another kind of digital currency. It has to prevent double spending as well. So those are the things that are similar about Bitcoin comparing to a conventional currency, US dollar. There are some problems, or there are something that can be improved about the US dollar. So with US dollar, you implicitly trust the place where the dollar is minted, that is government mint, and also you trust credit card organizations, let's say Visa. These are trusted central authorities. Basically, they control the creation and the circulation of the money. But are these places really trustworthy? As an asset holder, you may not want the government to withdraw a transaction after it is being settled. You may also don't want the government to freeze your account. Right? Also, in some foreign countries, you don't want the government to inflate the currency arbitrarily. Let me use an example. Recently, Zimbabwe, African country, has some financial crisis. So what the government does is they inflate the currency significantly. And here you can see a dollar bill with face value $100 billion. And with this dollar bill, what you can actually buy is regular stuff. Let's say a bicycle. Okay. So in this way, government can depreciate the bank saving of your account. And you probably don't want that from happening. So this sort of a drawback of conventional currency motivates Bitcoin or other cryptocurrencies. one of the design feature is to get rid of the central authorities. And this is what we call a decentralization. In this case, the money holder of Bitcoin does not need to trust US government, Visa, or any other single centrally trusted authority. Instead, they trust all people on the planet who get participated in building this global network of Bitcoin, which I will talk about later. The second principle that motivates the design of Bitcoin is transparency. As I mentioned before, transaction history has to be recorded when it comes to the design of any digital currency. In the credit card case, the transaction history is recorded in a ledger database that is private to, let's say, Visa. You cannot see what is going on in Visa's database. But in Bitcoin, the idea is that to expose everything to the public, so this transparency can invite trust. And the third idea is in order to realize these two features, decentralization and the transparency, the design of Bitcoin automate the entire process related to the money flow, as I mentioned before, which is money creation and money circulation. By automating this whole process without too much human labor involved in it, it allows to reduce the transaction fees. So that's why when you do transactions using Bitcoin, the transaction fee is much lower than what you pay in US dollar. For example, if you want to purchase a house in Bitcoin, the transaction fee is typically much lower. And so far, I talked about the concept of Bitcoin. You may wonder how it is related to the title of today's presentation, where blockchain is mentioned. So in digital currency, ledger is where transaction history is maintained. In Bitcoin, blockchain is Bitcoin's ledger. So basically what is recorded in blockchain is the history of transactions that are done in Bitcoin. Okay. So let's talk about the second part of today's presentation, which is about the application scenarios and interfaces exposed by blockchain. So here I want to treat blockchain as a black box and try to see what kind of interface is exposed by this black box. Meanwhile, as an end user, you can play what kind of roles you can play when you interact with this black box of blockchain. I will mention about 3 scenarios. The first scenario is about doing transactions, which is the main purpose of having the blockchain in the first place. So, as I mentioned before, for any currency, you have to sort of get the money, create the money first, and then you can use the money, spend the money in transactions during the circulation phase. Okay. So in Bitcoin, it's the same thing. In order to get your first Bitcoin, you can interact with some currency exchange services, such as Coinbase, CoinDesk. Basically, what you do is you download some app and in your, let's say, install it in your mobile phone, and then use US dollar to purchase some Bitcoin. Okay. After you get the Bitcoin, you can then do transactions in Bitcoin. So sort of in a similar way, with US dollar. You can buy stuff and also you can sell stuff. Okay. Or you can treat the Bitcoin as a digital asset for investment. So you probably heard the price for Bitcoin surges very recently. Right now, this is in the bottom part of this slide. You can see that's the screenshot I got from Google, which says about the price of Bitcoin. Basically, you have to pay about 20,000 US dollars in order to get a single Bitcoin. And if you look, zoom into the slides, you can see there is a sort of a trend. The price grows like exponentially in the second half of 2017. Okay, and this basically says this is a good opportunity for investment. Okay. So this is one way you can get your first Bitcoin, which is through this external currency exchange services like Coinbase. Another way you can get Bitcoin is through what is called mining. Okay. So the way it does is in Bitcoin mining, if you can purchase some hardware and use this hardware to do some kind of computation, and then the Bitcoin network or blockchain network will reward your computation with something in Bitcoin. And here I mentioned the computation is a kind of a special computation. It's a nonsense computation in the sense that this computation does not solve any real-world problem. Okay, so what it does is it will solve some computational difficult problem and then use this problem as a proof of the computation and that you spent, let's say, 10 minutes solving this problem without any cheating. So with this proof, the blockchain network will likely reward you. So basically, the idea is that the more you invest in purchasing the hardware, the more likely you will be rewarded in Bitcoin. So the probability depends on how powerful your hardware is. After hearing about this, you may be interested in mining. So as a potential miner, here are the things you have to keep in your mind. First is how much is your budget? When you buy a hardware to do mining, you may think about what's the constant capital. For example, the money you spend on purchasing hardware to run the computation. And then because the computation has to run continuously, it consumes energy. So electricity consumption, that is the variable capital. Other than that, the way blockchain give out the rewards in Bitcoin is very much like competition or like a lottery in some sense. So if there is only one player in the lottery, then you will definitely be the winner. But if there are millions of players, then the probability you get the reward will be very small. So here you should keep in your mind who are you up against in this competition. Nowadays we have a very large miner network, but also there are a lot of big players. For example, state-level miners, Bitcoin farms, and data centers. And some countries they have incentive to do the mining at state level. Here I use, let me use two examples. On the bottom left corner of this slide, you can see this is the national flag for Venezuela, which is a small country in South America. So Venezuela has a similar financial crisis, similar to Zimbabwe, as we mentioned before. But one unique thing about Venezuela is that it has a lot of natural resources, for example, gas. So instead of exporting the gas resources, what Venezuela does is they put a lot of gas into this kind of mining computation. So what they get back is Bitcoin. And the motivation for them to do this is that they don't have bargaining power in terms of deciding what's the price of the gas on the international market. So they don't want to export it at the gas at a lower price. By putting the gas into the mining process, they can actually earn more. So this is the same situation when it comes to Russia. Okay, Russia has a lot of gas resources, but it does not have the bargaining power as well. So very recently, Russia legalized Bitcoin. And on the bottom right corner, you can see a large array of computers. This is a Bitcoin farm. So when you use your personal computer or maybe some servers to do the mining computation, these are the players you are up against. And the probability, if you use your personal computer doing the mining, the probability you get a coin is very small. Of course, there are some solutions, and for this problem, you can join a mining pool to improve your probability. But let's save that for another lecture. The third scenario that I want to talk about is developing some applications on top of blockchain. So blockchain, if you think about it as a software system, it exposes some kind of interface, allowing you to develop a novel application on top of that. So here the conventional application is related to finance, financial technology or fintech. The applications are related to insurance, trade, risk management, and accounting. So for example, if your company runs ERP software, there is a possibility that you can adapt ERP software to the platform of blockchain. You can also use blockchain to do online merchandise and support micro payments. As we mentioned before, Coinbase, CoinDesks, they are sort of a wallet application in Bitcoin. And you can also support currency exchange. Of course, there are some other domains that are relevant to blockchain. You can use blockchain to support legal applications. For example, signing contract, supporting medical or healthcare data sharing across different institutes. And information technology or information system can also be supported on top of blockchain. So blockchain is said to be such a disruptive technology that will revolutionize many industries. So let me talk about a little bit detail about how you can develop an application on top of a blockchain. What kind of interface does it expose? So first of all, this application or distributed application on top of blockchain has its architecture consisting of two parts. One is the program or the program and data that execute inside the chain or on-chain part. The other part is the data that has to be stored off-chain. So when you design an application, you have to think about what kind of data should put inside the chain and what kind of data should put outside of the chain. As I mentioned before, one of the key idea of blockchain is transparency, which means that everything you put in on the chain, it will be exposed to the public. Everybody can see it. So it may not be a good idea to put, let's say, something private, password on the chain. And the way to interact with blockchain is through this transactional API. Okay, what this API does is it allows you to record the transaction. So send the transaction, and that's the, if you think about this as a software function, then this is the signature of send transaction function. It has 4 fields: sender, who sends the money, receiver, the recipient of the money, and the amount of money involved in the transaction, and some note. By analogy, the interface exposed by blockchain is very much similar to a personal check, right? So when you write a check, what you do is you write the recipient of this transaction, the amount of the transaction, and if you zoom in and look closely at the check here, you can see there is normally there is a memo field over there. Okay, so the memo field in blockchain transactions is very useful for extending the functionality of blockchain to support some novel applications, which I will mention it briefly later on. Okay, so this is the sort of a platform we have to deal with, the interface we have to deal with, but when it comes to the application building, there are some design issues. The first one, as we mentioned before, is how you can partition the application logic into these 2 parts. One is stored on-chain, the other is stored off-chain. So anything that is private should be kept off-chain. The second is whether or not you should involve some party in your application to do the mining. If there is such a need, you may want to think about what's the incentive scheme to reward them doing this computational expensive stuff. And there are some limitations of blockchain. One limitation is, for example, when you send a transaction to the blockchain, it takes a while for the blockchain to digest it and to store it permanently on the chain. Normally, this delay is about 60 minutes or 1 hour when it comes to Bitcoin. And when you use this blockchain to store some metadata of your application, you have to think about the delay that has to be there in the blockchain. So one application is Bitcoin wallet. For example, if you are some developer in Coinbase, you may want to develop a wallet application that is built on top of blockchain. And the wallet application deal with personal accounts, right? So the personal account part, including the password and some secret keys that are necessary to do the transactions, has to be stored off-chain in some place that is secure, while the transaction itself can be put on the chain by calling this send transaction function, as I mentioned before. Okay. So we talked about the application scenarios, 3 scenarios with blockchain, and a transactional interface with blockchain. The conventional application for blockchain is financial application dealing with money movement across different parties. But blockchain itself is not limited, just support financial applications. the innate security feature of blockchain allows it to develop applications in other domains, which is the topic for the third part of this presentation. So there are several security features that I will mention about it. The first feature is immutable storage. Okay, when you treat blockchain as a storage engine, basically it has the following three features. First, the blockchain data or content is readable by the public. So this is the requirement of transparency. Anything you put to the blockchain, once it is permanently stored there, anyone can view what's the content inside the blockchain. So it's readable to the public. In terms of right, it is appendable by honest miners, by some, let's say, by some decentralized authority. Okay? And the third property is immutability, which means that once the transaction is settled in the blockchain, it cannot be modified. It cannot be modified. And this immutability property is very useful when it comes to building some legal applications. For example, you can use blockchain as the underlying infrastructure to build a trusted timestamp service. Okay, and you can use the blockchain to sign the contract, to store the patents in application. Okay? And since the blockchain is always there and cannot be changed, so it is useful to solve the dispute. The second security property is no double spending. Remember, in the beginning of today's presentation, we talked about double spending. That is one of these two threats against currency design. So in Bitcoin or blockchain system, every transaction has to be validated to ensure that there is no double spending involved. Okay? And this property can be used to build what is called smart property. As a quick example, you can use Bitcoin to build smart ticket. And here, the smart ticket is smart in the sense that it is coupled to the Bitcoin. In real life, let me use an example. If you go to Yankee Stadium to purchase some tickets in box office, what they give you is a physical copy of paper that represents the tickets, right? And then you use the tickets to get admitted and sit somewhere during the game. The idea of a smart ticket is that instead of the boxing office give you a paper ticket, it gives you some Bitcoin. Let's say I use 20 Bitcoin for 10 Bitcoin. That is coupled with some concept of tickets. And then I use this 10 Bitcoin ticket to get admitted when the game is on. Okay. One of the benefits of using smart ticket is that it inherits the no double spending property or anti-counterfeit property of Bitcoin, so that you cannot duplicate the ticket easily. While in real life, without a smart ticket, when you use barcode or you use a paper ticket, it's very easy to duplicate. Someone make a photocopy of your barcode can easily use the barcode to be admitted during the game. The third security property is unstoppable execution. Here I have to talk about a new sort of programming interface exposed by blockchain. Previously, I talked about blockchain as a storage engine. Okay, it supports this send transaction API. But the latest version of blockchain, especially in Ethereum, it supports some programming interface. And this programming interface is called smart contract. Basically, smart contract is a program that can be executed in the blockchain. In Ethereum, the language is called Solidity. Okay. So one security property when it comes to smart contract execution is that once the smart contract program started execution, it cannot be stopped. So this is what we call unstoppable execution. If you watch the movie Terminator, you probably heard the term Skynet. Skynet is known to be operated by the AI. One of the property there is it cannot be stopped. Okay? So in some sense, blockchain is similar to Skynet in the sense of unstoppable execution. And this unstoppable execution is very useful when it comes to transactions. So in transaction, when I pay you something, in order to be fair, I need to receive something as a return, right? So if the execution of the smart contract can be stopped in the middle, then I already paid, but the program stopped before I receive the good from you. Then this will result in an unfair situation when the sender already sent the money, but he does not receive the product from the receiver. Unstoppable execution is very useful to ensure this transaction fairness. By exploiting this feature, you can build many applications on top of a smart contract interface. Basically, you can implement some logic that decides how to spend the transactions. So here, let me use an example. A stock exchange can be built as an application of a smart contract. If Alice wants to trade 10 shares for $10,000 when the stock price is below 1,000, then then that logic can be implemented using a smart contract. Okay, the smart contract will constantly check the stock price. If the stock price is above $1,000, it will not do anything. It will continue to run. But if the stock price goes down and is below $1,000, then it triggers the execution of the transaction. It will send the transaction. And then between Alice and Bob, they will exchange their money and the stock shares. So the last part of the presentation is about the internal mechanism of blockchain. So we mentioned about several APIs, let's say the transactional API and the smart contract programming API of blockchain. And there are some security properties associated with these APIs. So here, I will very briefly talk about the internal mechanism of blockchain. How does blockchain achieve this security property? Due to time constraints, this will be very brief. So one property about blockchain is immutability. And this has something to do with the transaction storage of blockchain. A blockchain network typically consists of two layers. As you can see in the diagram in this slide, it consists of a P2P layer that where transactional clients submit transactions. And another layer is miner network. The miner network runs this very expensive computation and try to figure out which is the right transaction to be included in the blockchain. Okay. And the blockchain network runs consensus protocol to decide the transaction that is valid, and also it does not have any double spending, and include those transactions into the blockchain. Okay. In order to realize this design, as we mentioned before, it has to support these two sort of functionalities with any currency: create money and circulate money by transactions. In blockchain, this is realized by using cryptography. During the money creation time, the blockchain, it plays the role of the mint, which means that it will sign a statement that basically says that the coin X is just being created. And the blockchain, during the money circulation, for example, if Alice pays Bob with coin X, then what it happens is that Alice, as a client, will sign the statement using her private key. Okay? And what this statement says is that coin X, which was previously belonged to Alice, is paid to Bob. And after that, the blockchain will play the role of Visa. It will validate this transaction, whether or not there is any double spending, whether or not Alice indeed have enough coin to pay in this transaction. When you materialize this design, the one key problem is how you are going to represent the transactions. For example, how you are going to represent the coins, owner's identity, and the ownership, which means the binding between some coin and owner identity. So the coin in the transaction is represented by hash pointers. Very briefly, let's think about the transaction where Bob spent some coin. And this coin spent by Bob will be represented by a hash pointer points to a prior transaction where Bob received the coin. So you can illustrate this idea in the diagram in the slides. Right? So in these slides, you can see there are two transactions represented by two boxes in the bottom of the figure. So the left box represents the current transaction where Bob will pay Alice with coin X, and this coin X will be a pointer that points to a prior transaction where Bob received coin X from Charlie. And this figure also shows the hierarchical structure of blockchain as a storage. So you can see at the top level, it is a series of blocks. Okay? And each block consists of multiple transactions digested using some cryptographic schemes called the Merkle tree. And at the leaf level of this Merkle tree, we have individual transactions. And individual transactions are represented by different hash pointers. Okay? So we talked about the blockchain as a storage engine. But the next problem is when you have a new transaction submitted to the blockchain, how does the blockchain get included? Sorry, how does the transaction get included in the blockchain? So the general workflow is illustrated in the figure in this slides. you can see after sending the transaction has a state of pending. Okay, then the blockchain, all the miners in the blockchain network will try to validate whether or not this transaction is legitimate or not. Basically, the validation involves with checking the entire transaction history to find out whether or not there is double spending and whether or not the sender has enough money in her balance and to pay this transaction. And then after the transaction are being validated, then all the miners will run this mining computation. What it does is it will try to solve a computational difficult puzzle. If there is one, the first one that solves the puzzle will be the one collecting the reward. And that one will decide what is the latest chain will look like. Okay, and this latest chain will then be broadcast to the entire network, to all miners. Okay, for the mining part, its design is sophisticated. Okay, it involves with some randomization in it, so that you cannot say once the transaction is submitted, it's immediately settled. It will take, as I mentioned before, 16 minutes to finalize a transaction in blockchain, in the Bitcoin case. Okay. And the computational expensive puzzle is designed in such a way that nobody is able to cheat. And this has something to do with proof of work design. So the idea of proof of work is that if you did do some computation, then you can claim, you can present this proof. Okay, but if you do not spend, let's say, 10 minutes doing the computation, if you want to claim you did the computation, it's very hard to forge the proof. And also, the mining process, it plays the role of a mint. Every 10 minutes in Bitcoin, it will give out 10 Bitcoin. Okay, a quarter of Bitcoin as a reward to the miner. Okay, so this wraps up the presentation today. We talked about the Bitcoin and the underlying back end that support Bitcoin, which is blockchain. We talked about the application scenario of blockchain, the sort of interface exposed by blockchain if we treat it as a storage engine and a programming platform. And then we talk about the security property exposed by blockchain. After that, by the end, we very briefly talk about the internal mechanism of the blockchain. So if you have any questions, I'm ready for the questions. Other than that, thank you for your attention.
Hey, thank you, Richard. That's a very interesting presentation. This is certainly an interesting technology. I guess one of the questions I had as you were doing the presentation, we were talking about the issue of trust and in a standard financial the conventional financial system, there's that central authority, be it a bank or the credit card company, or so you don't have that in the blockchain now. And on one of your slides, I think you said instead of trusting the bank or the government, we just have to trust everybody on the planet, all people on the planet. Yeah. Yeah. So I think that might be, I think there might be a potential issue there. I'm not sure if everyone on the planet is trustworthy. So I guess I have some concern there.
Okay. Yeah, I sort of exaggerated the situation a little bit, but that slides, I think it's slide number 9, is presented from sort of a philosophic point of view perspective. So
Sure.
the idea is that the sort of starting point of designing a blockchain network is open membership. It try to be as open as possible, so that anyone can join the blockchain network and doing mining computation over there. So if we have a large population doing the mining, then the underlying assumption is that the majority of people, they are trustworthy, they are honest people. Hackers and other people that are malicious, those are minority. So it's very unlikely they will take control of the entire network. So that's the sort of perspective of presenting, of saying we trust the entire population rather than just a small number of big players, authorities.
Sure. No. Yeah. I was just I was just amused by that. So I appreciate the I appreciate the you're humoring me on that one. So let's get to some of the questions from the audience. So I know one individual, when you were talking about the mining, they had a question about grid computing. Is that something that's utilized for that miners might use in this field?
So for grid computing, if I understand it right, the way it does is a form of P2P network where each node plays the role of computation, right? So if we compare a conventional grid computing network with blockchain, the key difference here is that grid computing is doing some computation meaningful, right? So it does. So for example, SETI at home is I think that's is an application for grid computing, which is used to find some life using signals received from outer space, right? So it does some kind of useful computation. But for blockchain, the computation, as I mentioned before, it does not serve any useful purpose other than just to make sure nobody is cheating. So in this sense, they are different. But other than that, I think the infrastructure, architecture, they look the same, right? So they are all based on P2P network. So I think there is a possible way to integrate these two fields together. And I think in real systems, there are some preliminary work or pilot work, and that does integrate these two together. It's called Grid Coin, if I remember it right. It's Grid Coin. What it does is it uses blockchain as an incentive platform to grow the grid computing network, so that if you are someone interested in doing some meaningful computation, then you join grid coin network, doing some computation for some other scientists or researchers. And what you get as a reward is Bitcoin. So I hope this answers your question to some degree. I think they can be integrated together.
Okay, thanks. Appreciate that one. So one of the attendees is interested in like what type of language might be best suited for working on the construction of the blockchain. Is there do you think one language is better than another to work on this technology?
So I think in terms of language, I guess the most popular one is Solidity. Solidity is the smart contract in Ethereum network. It has this. So I think it's object-oriented language, and it is very easy to learn. I think if you have background in some other high-level languages such as C and Java, it's C++ and Java. Sorry, it's pretty much in terms of the syntax is pretty much similar to those conventional high-level language. But when you develop applications on top of blockchain, I think the most difficult part is to get it correct, to get it right in terms of security, because the smart contract program is dealing with money movement, right? So you don't want to be wrong about who will be the right recipient of the transaction. And this, I think, is not particularly, it's not a language problem. It's more about how you can design your application, your program, and securely. So if I, back to your question, if a language has to be recommended, I think Solidity is a very good starting point.
So just to follow up on that, then I guess my question is Solidity specifically for Ethereum, or can it be used for Bitcoin or any other, or is it specifically tied to the you had it kind of listed under the the Ethereum application?
So yeah, Solidity is tied to Ethereum. But the concept of smart contract is generic. In Bitcoin, it has its own scripting language, but it's not as general as Solidity. At least that was the case like a couple of years ago. I did not catch the latest case. The Solidity is Turing complete, which means that it can implement any functions. But for Bitcoin script, it's limited. It does not allow you to implement any logic. It is limited in terms of what kind of application it can support. And in some other private blockchain, they also have their programming interface. Back to the question, the Solidity is specific, but smart contract is sort of general. I think for any blockchain platform nowadays, you can find some kind of programming interface over there.
Okay, great, thanks. So one of the attendees is asking if does blockchain require the use of cryptocurrency? Are those intrinsically linked together, or is that just something for the financial aspect?
I think blockchain. So this, I think different people will have different answer for this question. But from what I view, I think blockchain is generic. It does not need to be tied to the application of cryptocurrency. As I mentioned before, you can build non-financial applications on top of blockchain. For example, you can build some kind of archiving service on top of blockchain, which stores patents, things like that, to resolve dispute, right? So in this case, there is really no money involved or currency involved in this kind of application. What a blockchain essentially is it allows you to store some information in a secure way, and the security here is defined in the third part of the presentation over there.
Okay. Let's see. I see we're we're already past our time for today. Now, there are still more questions, but I think we'll try to wrap up for today. But maybe we can touch base with you afterwards and try to get some answers to the other questions that came in, and get some feedback to our attendees. So once again, I want to thank you, Richard, for taking the time to to give us this overview. It's it's a very interesting technology. I think it's one of these disruptive technologies that may change the way we've been doing things for a while, and so it's good to try and gain an understanding of what it is and what it might mean for us here in the future. So thank you for enlightening us on this topic. We appreciate it.
Yes, you're welcome. And yeah, definitely I will answer the question offline. And thank you. Thanks everyone for your attention and your time.
Okay. All right. Thanks again, Richard. And thanks for everybody for attending today. And like I said, we'll try to get to your questions, get you some additional info and feedback. And I'd just like to take this opportunity to wish everybody, I hope you all have a happy holiday season, and we look forward to seeing you back here sometime in the new year. So once again, have a good holidays, and we'll see you next year. Thanks. Bye-bye.
Bye-bye.